San Francisco makes me sick. I came to San Francisco and got in the back of a car and drove up to Napa, and I don't drink, so it wasn't the winery tours. On the way back, I managed to get this cold, and I'm sorry. How many people here run IPv6 on their networks? How many people don't run IPv6 on your networks? Liars. It's all tunneled. Okay, so what I decided to do when asked to chair this thing was to get the perspective of a couple of different players. So what we have Steve, who is not a player anymore, and we have Brent Sweeny from Abilene. How many people know what Abilene is?
Abilene, the city?
No. Abilene,
No.
Well, yes, whatever. So Brent's going to talk a little bit about Abilene for those of you that don't know that and explain what that is. And then Ed Lewis, who is the reliable curmudgeon from ARIN, is going to talk about what the customer demands and the problems that the customers have. And then we're actually going to get a real-world commercial service provider to tell us why this is such a good idea. Right? And that would be Rob Rockell from Sprint. We will take questions at the end. Brent? Oh. It's a Mac. It's a new Mac. How do I do this, Ed?
Are you still on? Would you just work?
It's a Mac. It doesn't work.
Are you on the right? Oh, he was. Okay. Oh, it's on the second display. That's right. Okay.
It's on the second display.
Yeah.
I just acquired a Mac, and I have no idea how it works.
Just have faith. You can see it. Say, I can see it. I can see it.
Slide it over to the other window.
Yeah. Let me try this.
I think Ed's knowing how to do that, but I certainly don't. So I'm learning.
Oh, there you go. Guessing. You can see that. Let's do this.
It's been like this since yesterday morning, so...
Ed, you are a king.
Got it.
I'm looking for.
You're looking for control or open Apple L or whatever it is.
Yeah. What's the? Is it different package? Yeah.
Ha.
Yay!
It takes 3 engineers to bring up a presentation.
Where's Bob Metcalf? No, nobody remembers.
Not his fault. Okay, I'm from Internet2, which is also called Abilene for. Actually, that story is not in here if you want to know. The reason is because Internet2 rides on Quest Fiber. Quest Fiber was built along railroad lines, and they picked one of the old railroad towns called Abilene and named the network after it. So that's where the name comes from. I'm from Indiana University, as I'll show you in a second, where we talk about what Abilene is. For those of you who don't know, you'll see what our role is. So these are some of the things I'm going to talk about. Basically, first of all, just sort of an introduction to what Abilene is, how we did V6, what we're doing to help it along, and some of the things that we think that are missing that would be helpful to have with V6 on our network. So, first of all, the question just what is Internet2, and also one little slide about what it's not. Internet2 is an association of the universities in the United States, the major ones and a few minor ones, and it created a project to create a network, which became Abilene. You can think of Abilene as the primary research and education network in the United States. It connects all of the major universities, most of the smaller universities, many of the K through 20 networks in the States, a lot of other kinds of research institutions, libraries, labs, and many of the other peer networks that are like it. It's been operational for almost 6 years now, and Indiana University operates it for Internet2. It has an OC192 backbone as of last year with 11 core locations around the United States. I'll show you a map in just a second. a summary of a bunch of the connections. We have 46 physical connections that range from OC3 to 10 gigabits that somehow reach about 242 member universities that are generally part of what we call gigapops, sort of an aggregation site that is generally regional in some way. Some of them are historical, remnants of the old NSF regional networks. In addition to that, there are a number of what we call sponsored institutions that are not real members, but are important enough and desirable for the connections and the work of the universities. So some of these include the big Gemini telescopes in Hawaii and Chile, lots of labs, the Smithsonian libraries, and so on. In addition, there are also, at last count, 33 state research and education networks. Those are mostly K through 20s, but they also include a lot of the smaller colleges, not the big major research institutions, and so on. So generally, and kind of gradually, it's reaching the kind of the educational infrastructure of the country, all the way from the big research institutions to the small schools. We also, and this is pretty important, have, in addition to connections to some research and education exchange points, as you can see in Seattle and DC and Chicago and on the West Coast here at May West and Miami and New York City. We have 48 connections to 31 different research and education networks that are mostly foreign. So there are research networks like Internet2 in Canada and Mexico and all over Europe, in Asia, South America, very little so far in Africa, but just about everywhere else. And we talk with, one way or the other, with probably all of them. So it's a large research educational community. There are also a few non-university members, people like Microsoft Labs and Johnson & Johnson, and some people who either do a lot of work with universities or in some case want to use some of the advanced protocols that we use and want to talk to each other. There's a lot of support for what we call advanced protocols, multicast and V6, some other interest in some other things that are related to those. So there's the really busy map. You can find it on our webpage and look at it, but basically this is the full members, not the kind of ancillary sites. You can see the kind of gold lines that connect the core network. That's the OC192 backbone. And there are a fair number of 10 gigabit and OC192 connections to some of our sites. And all the major universities you can think of, I think, are there. This is the one slide that I mentioned that will talk about what Internet2 is not. As you probably inferred from the discussion of V4 connections, some people still believe that Internet2, and will tell you in Slashdot and other places, that Internet2 is an IPv6 network, and just an IPv6 network. Well, it's not. You guys are smart enough to know that and probably why. But it's we run IPv6 natively across our backbone in the same way we run V4. It's a production service. It's important to us. It's coming along. We're trying to nurture it a little bit, but we're not just a V6 network. So how did we do it? We have native V6 running dual stack on all of our core nodes. When we first started this, we had Cisco GSRs. About 2 years ago, we started converting over to Juniper T640s in a second generation of the network. But it ran well on the GSRs. It's running just fine on the Junipers. We still have a very few tunnel connections to people whose infrastructure in between us, the gigapops, aren't running V6 yet for some reason. So we still have a few tunnel connections. We configure V6 on the same interface, and it runs over the same physical path as V4 does. When our network first existed, we were using OSPF for our IGP. OSPF version 3 didn't exist at that time, so we decided that we wanted to use the same IGP for both V4 and V6, and so we converted over to ISIS. There was a talk about that by my colleague Grover Browning at NANOG a year ago, and the reference to that's given there. That talks mostly about how we did that transition, how we brought them up in parallel for a while and then converted from one to the other, and some of the kind of gotchas that we saw with that process and some things we had to kind of think about for the first time there. We mentioned that the full IPv6, and we think this is the full IPv6 routing table. Perhaps someone has another view of that, but we peer with the 6-bone, and we don't have peering yet with the European 6NAT, so we might see some more there, but we're getting things from Shayant. One of the really interesting things that we're seeing is that in places where we have 300 or 400 V4 prefixes from some state network, we're seeing generally one prefix from them for V6. That the aggregation that you know is supposed to be there for V6, so far in our experience, is really there. It's certainly reducing the size of the routing table. Out of the 52 connections we have to gigapops and exchange points, our exchange points, 28 of them have V6 turned on them. And out of the 48 connections to peer networks, both domestic and foreign ones, 29 of those have V6. Tiny bit of multicast. It's one of the things that we're interested in working some more on, but it's beginning, but it's very, very small and has some problems, as I'll talk about in a second. So our V6 map is much sparser than the V4 map, but that's what that looks like. The yellow ones that show up on this one are still tunneled. So there are a few major players like the Ohio network that's still a tunnel network, but lots of people are native, and more of them are coming along. One of the things we try and encourage our users to believe is that V6 performs well, that it can do as well as V4. You know that you've got routers that are highly tuned to run V4 efficiently. And we're seeing that not only the network interfaces, but also the routers are being able to pass V6 essentially as well as they do V4. Bill mentioned that this graph is very boring. You can barely see along the very top of the graph a bunch of little red dots, maybe if you're really lucky. And it's just flat and boring. These are with 1 gigabit NICs in all of our POPs that we run performance iPerf tests across the country. So this is showing iPerf tests throughout a day between Washington, D.C. and Sunnyvale. You can see the results from all of those at our observatory. There's a reference to that at the end. One of the kind of interesting things we've done is put what we call an observatory in all of our core nodes that people can. Part of the intention is that we'll try and use it to instrument the network, but also that people can run experiments across our network using those devices. And also sometimes, for instance, in the case of Planet Lab, put their own devices in our racks and run tests. This graph is not as flat. That's a good thing, but it's slow. So you can see that the graph is starting to pick up. This is 2004 in here. I've got one. Could you see it?
No, I didn't.
Look, let's see. Look, there's a little dot.
We need Avi's green.
We need a green pointer. We'll do with red. So what are we doing to help it? Obviously, we have to create a network where we believe it works well, where it's supported. Of course, we started with 6-bone and 6-bone addresses and peering there, and then as people are able to, we're doing more and more native peering and more native addressing. We use native addresses across our network and with all of our peers, and as I'll show in the next slide, we're also giving them addresses out of it. We have an open policy for V6, and I'll talk about that a little bit more in another slide. We're setting up some 6-to-4 gateways and also helping people find the ones that exist for people who still are only on V4. I mentioned measurement support a little bit already. So we have a /32 from ARIN. We're using that to give allocations to all of our members. Generally, we give the gigapops 40s, and there are a few directly connected universities that we give /48s. We don't give addresses to the peer networks. We expect them to have their own. We try and show people that it's working well, as I showed from the observatory graph, but also other things. We're trying to help them build confidence that they can implement it and use it. There's an Internet2 working group that provides a fair amount of support and education. The reference for that group is on the references at the end too. We talk about it. We have some kind of what we call a cookbook that shows people how they can do it. And then I think most importantly, we provide hands-on workshops around the country for people to come from their own areas to try it. We set up a lab. It's not just an in-house lab, but it's also connected to the Internet2 backbone. And the people come from their area. They sit down and they create a V6 network in the lab that's connected out to the world. We talk about some history and some theory, but as I say, it's aggressively practical. We try and make all the things we talk about relevant to what they're going to do and what they need to know. They go through the router setup with Cisco's and Junipers. We talk about how to both to aggregate and how to divide up your address space in a sensible way, how to allocate addresses, how the hierarchical addressing should work, and how they would think about that in different ways. We talk about some of the applications that are there, and if we have time in the workshop, we actually play with some of them, and they can see that most of the applications that they know and love are going to work there. We talk a little bit about different ways of architecting it on your network, and some exposure to what I call some of the tough topics. Multi-homing is still a problem. And the slides for the classes are there in that reference. We think that those are really successful and are helping with whatever growth that we're seeing quite a bit. Our policy basically is that unlike V4, where we don't peer with commodity providers, we don't transit V4, there's no default. All of our connectors are expected to have commodity connections too. So all of the universities have connections to you folks as well as to Internet2. But for V6 and for multicast, we allow any prefixes, except for this obvious stupid ones, and we will allow people to have commodity peering and to share those prefixes with us. The purpose for that is to help to bootstrap it, to help to get it to be used and help it to get where people want to go. Part of that, of course, is because there's still a lot of places if you have commodity peering that you can't do with V6. A lot of the peers don't offer that yet. We're going to hear about how Sprint is doing that. And how long will this be AUP free or have a relaxed AUP? And that may be forever. We also, just as a matter of policy, mark V6 prefixes that are coming in by a less desirable path. In this case, it's usually tunnels, in order to help people kind of choose between them. Since you've got highly aggregated stuff, and if you have more than one way to get there, you want to pick a high performance path as opposed to a low performance path. What are the things that we think are missing? One of the biggest ones is being able to count it. There are no ways right now well, there are ways, but there are no good ways to be able to count V6 packets. You want to know how much traffic there is difficult to do. The V6 MIB is not well developed there, not well deployed. So it's easy to do throughput and latency, as I showed you, but not easy to do packets and bytes, unless you do special things like having sub-interfaces, separate interfaces, separate networks in some case. So the way we're doing it right now is using per-interface firewall filters and marking all and trying to count the V6 stuff. That's generally working pretty well, but not always. There's no V6 net flow. That's a big deal. That's important. Lots of implications for that. Multicast, you can do multicast until you want to do it between ASs or between domains. There's no good inter-domain solution that's deployed today. There's a future and there's a path through that, but it's just not there yet. And so right now there's a single RP. It's in France. You can do RPs for different groups. Embedded RP is probably the way out of this. Multi-homing, as I mentioned, is still a problem. There's no RIDB support for v6. The RIRs will give you v6 allocations. You can SWIP them and all those things, but you can't register them in the RIDB.
It's coming soon.
It's coming soon, Susan says. It has been coming for a while. But, you know, as far as what the problems we saw, you'll hear about some of the problems in some of the subsequent presentations, but we have actually seen very little. There's some people who have problems with trying to use router code, trying to find the right router code that'll work. There are some things that are fairly obvious to BGP users, like making sure that you originate the prefixes, and you know, nobody originates /32s, so you have to stick that into your IGP and stuff like that. Router IDs are 32 bits, you have to think about that. But generally speaking, and this is the message that we're trying to give people, is that it just works. You should do it. Some things about what we're going to do in the future. We're trying to expand our exchange point connection so that we can peer with a lot more v6 people. For instance, we used to peer with Hurricane Electric in Chicago. That connection went away. We're looking forward to peering with them and many other people at PAX soon, any day now, I hope. Pacific Wave in Los Angeles is a new exchange point coming up soon. You know, we want to see multicast work more robustly. We have a goal, a stated goal, using it in quotation marks, of having IPv6 everywhere by 2006. That's sort of an I2 goal. We hope that we can see that move forward. And here's some references. You can see those in the slides, and I'll make way to the other people. I think we've decided to have questions at the end of all three presentations. So if you have questions, I'll be glad to talk with you after a bit.
It pays to be in the academic community because you can break things.
Breaking is good.
Ed is our next speaker, I think. Yeah, Ed. I'm not going to introduce you. Ed, if you have problems with address space and you're having problems with ARIN, Ed is not your man.
Okay, I'm going to presume that most people here know what ARIN is, I guess for other reasons. I'm going to talk about, this talk is from the perspective, we're a customer to ISPs for v6 services. And it'll be a fairly short presentation since it wasn't much work to do this. As far as the network is concerned, ARIN is an enterprise. We don't have transit, we have a simple topology, we have a few locations, nothing really terribly exciting as far as serving up our data. What we've done to date in terms of bringing things on v6, we brought up DNS servers. We have all of the zones that we serve one way or the other as a slave or master of the zone. We have our HTTP version of the website as opposed to the HTTPS, that's what I mean by secure and unsecure. If you've come to our website, there's a little place where you can type in information to get a who is search. That search works on the v6 website, but it does it through a v4 proxy. And we have FTP also running on v6 also, and we're working on the other services. Notably not here is the who is service, which is one of our big hitters. IPv4 right now, to give you an idea, I just want to give you a basic idea of where we came from in the transition. And in v4 we have two locations. We have an office in Chantilly, Virginia. We have a colo site that's a few miles away, not very far away. And we have network operations coming out of both. We serve data from both places. We also contract out for services offered by other vendors too. So we have basically things in three places as far as the network is concerned. Now, adding v6, we only added v6 into our office. We only have it at the office location in Chantilly right now. We're working on getting it to the co-location site in the near future. One of our requirements on the vendors was we wanted a native connection, not a tunneled connection. So we've been sticking out for that. In our offices in Chantilly, we have a v4 infrastructure already in place. We added to that by adding new boxes to the same physical hardware. We have a router, which is open source. I have the version information up there. It's Linux 2422. We have static packet forwarding going on. We don't exchange routes. We just pass the packets up back and forth. We have a firewall on OpenBSD. Nothing surprising there. We didn't go for any commercial packages at this point. We just wanted to bring this up and running. Oh, that button.
It's Mac.
It's a Mac. I'm not used to using Macs from other people. FTP and WWW services are two of the three services we brought up. The FTP server, it's dual stack. It's the v4 server, and Chantilly is also the v6 server. We use open source FTP for that. The version number is up there again. No problem. The website, same deal. We use Apache for our website, web server. Its version number is up there. The machine it's on is dual stack, but this machine is only running v6 for the web in this case. We're not doing, our v4 web servers are not the same as the v6 web server just because that's the way it is. To get the web forum whois queries done, we use the mod proxy plug into Apache. Fortunately for the people that did this, there were no big surprises, and unfortunately for me as a presenter, there's nothing to tell about it. DNS. I have more to say about DNS because I worked on it and screwed it up more. We started with DNS, we have DNS in three places. We have some at a vendor site which has high bandwidth, which is one of the main reasons why it's there, along with attention time. We have a higher bandwidth colo site, has a few DNS servers there, and then we have those that are in our offices. The challenge for the DNS was to serve all of our zones up without bringing those servers back home to where the v6 is. Now, to do this, I had to basically do non-dual stack DNS. And there are two ways to do this. You can either put a set of servers in your NS set that have only A records and those that have only quad A records, or a little bit of a mix of the two. In this case, the A records will be where the v4 service is, the quad A where the v6 service is. The other option is to be a little sneaky about this and say that for this one domain name, which is the name server name, it'll have an A and a quad A record, but those two addresses are in different machines in different places in the world. After talking to a few people about what was the recommended way to go, the observation was made that when bind goes out and asks for the address of a name server in doing its referrals, it asks for A and quad A anyway, so don't burn extra names. Every extra name, it will burn more queries, so we reuse the names of our v4 servers onto v6. And we end up with a thing called one name, two machines, which somewhat looks like this. The two red boxes up here are computers. This is one of our slave machines, tinny.arin.net. It has this A record in the DNS. It's physically sitting at the colo site. And if you go through v4 to get some of the data it has, you'll end up there getting data ultimately from there. In our office down here, which has the v4 and v6 services, we have another machine which we put the tinny label on it also as a quad A record. That machine actually has a few other machines at the same time. But we've done here is we've kept these two machines are both tinny. They're in two different places. Getting this to work required some backdoor zone transfers, which are not a problem in DNS. In bind, you can do that pretty easily. No one else knows about it for real. But they are asking different machines. This actually works pretty well, except for the gotcha that came up after I did this. When I was troubleshooting this stuff, I was using SSH to connect to get the shell account on the machine. SSH, like a lot of other applications out there, will prefer quad A's over A's. So it looks up the name, gets the quad A. If not, it gets the A and it goes there. What I did, of course, one time was trying to test one of the machines. I wanted to look at the log file and hit it at times. Well, as I was hitting the machine, the logs weren't moving until I realized I was at the wrong red box on the previous network. So you have to be careful when you do this to remember that the two machines are different. You have to be able to address them specifically. I was glad I wasn't doing RM at the time because my conf files are all the same, have the same name. So that's one little gotcha in doing this setup. Another gotcha we had, this actually came up earlier, we solved this up front. One of our name servers was serving other services also. I guess there's our whois server, a few other things. We weren't ready to bring the other services to v6, but just the DNS. So the little plan of having two machines with the same name wouldn't work there. Ultimately, we decided that we wanted to buy more hardware because new hardware is always good to have if you can get it. And we separated the names, the DNS from the other services and went ahead. my experience with this is all in Bind 9.2.3. I've stayed with just what we consider to be the last release of Bind. There are other versions out there. There are snapshots, there are betas, and so on. But we stayed with the what was called released code on Solaris and Linux. And in doing this, there were some bugs that popped up, and the bugs aren't important. I was just kind of amazed that I found bugs doing this because I didn't think I was doing anything that was that radical. But I don't want to be a pioneer, but apparently, maybe, I don't know. I don't want to be.
There are arrows in your back.
There are arrows in my back. As I told Bill earlier, I'm from the city. I don't like the frontier. And finally, summary, adding V6 to the network protocol, I took this from a slogan of the Baltimore Opera Company that it's not as hard as you think it can't be. It really is not hard to do this. It's not a hard uptake. Recommendations, latest versions of software is always good. The open source is always adding more and more V6 support, and as things are found, they're fixed. From a perspective of an enterprise, we don't need to have a V6 and a V4 separate network. It doesn't make sense for someone in as small an environment as we are. And one other perspective, too, is if you get in early as a customer, V6 traffic is not that heavy anywhere, so we get to get in now, set our servers up, see them work with light bandwidth and let it grow into the future. If we waited later, if anybody waited later, they're going to hit a higher traffic load and may have more panic situations trying to learn this new environment, which shouldn't be there. So, thank you.
That's it. Thank you. Okay, so that's what your customers are doing, right? And the trade-off between what the customers are doing, oh, you're not supposed to see that slide yet. And what the commercial side is doing, which is where most of you are, I think, Rob? Where is that? Oh, there it is. It's that Apple thing. This is Rob Rockell from Sprint, and I think this is the down arrow.
Gotcha.
And he's been doing V6 for
7 years.
as long as V6 has been viable. And we'll tell you why Sprint is in the position that it is today with regards to V6.
Can I stop you for 1 second, Rob? I'm sorry.
There's a virus creeping around in one system. What I'm going to do is give you, unless Larry disagrees, did you want? I don't want a name. I want the domain name in the. Yeah, this the Chinese telecom person. How will they know that they're the one? I don't want to give the name. Okay, should I email address? We have an email address. Should I do that? Moral dilemma here? I'm not sure.
Let Larry do it.
Larry's from Merit. We're both from Merit. We're responsible.
You should let Larry do it.
Should I get out the email address? No question in your mind that we should do it?
No question in my mind that Larry should do it.
The email address is joe@chinatelecomusa.com, so whoever has that email.
Go for it.
No problem. Hi, I'm Rob. I work at Sprint. I'm going to talk a little bit about our V6 deployment. Taking into account what these guys have said, we have a different set of circumstances we have to deal with, largely that whole profit thing. So it's driven a little bit of different set of behavior in terms of our deployment. So I'll go over, first I'll talk about sort of just what the network looks like. Then I'll go into why it looks like it does and some of the issues surrounding, all right. Okay, so there's our IPv6 backbone today, and don't blame me for the bad cartography at Visio, but we have the network deployed in a number of cities around the US as well as in Asia and Europe. I put a little bit of a marketing ism there saying it's a 10 gig IPv6 backbone. It is writing a 10 gig backbone, but we'll see that it's really not IPv6 when we get into talking about it. Hardware is largely low-end depreciated gear. We talk about sort of the pricing structure that the market is pushing us towards. You'll see why that's the case. So just going through a little bit of our deployment history, in 1997 we obtained 6-bone space. The original router sat in my desk. Started gathering customers slowly. Through 1998 and 1999 you sort of saw a linear growth of people being interested in the technology. In 2000, things started picking up dramatically. We got space from ARIN, the /35, which turned into a /32, which makes subnetting a hex a lot easier, by the way. So by the end of 2000, we had over 100 customers, and it was time to really deploy things out into the network on a larger scale. So throughout 2001 and 2002, we kept track of where the customer interest was and deployed sort of on demand to try to hit those locations. So we added a bunch of sites, including one in Japan and one in Brussels as we extended offshore. And you see throughout 2001 and 2002, you notice we actually have 2 or 3 people per week would be asking to connect to our IPv6 network. One interesting fact, if you look at what's going on right now, we have about 300 tunnels, but the actual number of connections requests we get is going down to about 1 per week. I can't tell if that's a fall off of interest or just the fact that IPv6 is more pervasive in a lot of ISPs, so people have a lot more choices.
Or the early adopters got in.
Yeah. So a little bit about our offering. The routers are IPv6 standalone boxes. We don't run dual stack. There's no dynamic protocol level interaction with any of the gravy train, the IPv4 network, Sprint link. We use GRE tunneling between the routers, and we use it over the IPv4 infrastructure. There's an IBGP mesh between it, and we're running ISIS as our IGP. It looks eerily like Sprint link, except for other things in hex. And so the reason for that is simple. From an operations standpoint, making things as cookie cutter as possible allows you to quickly fix problems, and so that's the model we took. So why we did it this way. First of all, why we took it and removed it logically from a protocol level standpoint away from the IPv4 network. Well, you have router OS dependencies. There's a lot of features driving the IPv4 network in certain directions, and there's IPv6 tends to be sort of a boutique value-added service that comes with your service. But you can't. We don't have the ability to run dual stack. The cross section of that feature set doesn't allow us to. Second reason it's done this way, the customer requirements. What you find is a lot of people want IPv6, but when you ask them what they're willing to pay for IPv6, the answer is no, we don't want to pay, we just want it. And so that whole for-profit thing kicks in, and so you end up doing, as a result, to be able to offer a service that meets the price point customers want, which is free, you end up having to dig around in your dumpster out behind your building to find the routers to deploy. You don't have a lot of capital funding to justify a zero revenue sort of project. So it's deployed out of a lot of low-end depreciated hardware that's capable of running IPv6 and capable of doing GRE termination, but it's not the latest and greatest in terms of hardware. Again, the overlay model removes those dependencies. Another good benefit of doing a tunneled network that doesn't interfere with the gravy train is it allows you to be more experimental. Things like multi-homing, micromobility, there's a lot of standards still being driven into the protocol. And the ability to be able to hack things together without interfering with the network and causing giant outages is important. And again, you'll hear this, the protocol isn't fully cooked yet. There's some issues that we're waiting for, and before you actually deploy it on a network that's going to get a lot of visibility if you break things, it's nice to have an area where you can experiment and wait till that protocol is fledged out. So what it allows us to do, the IPv6 is free. We're limiting it mostly to actual commercial customers and peers now, but we still are open to anyone that's topologically close to us, and it makes a sense from an efficiency and latency standpoint. We will turn up tunnels to you even if you're not connected to SprintLink. So the goal is to promote IPv6 within the current confines of IPv6. So one of the things that is a little different than the way Abilene deployed, we aggregate very strictly to RFC 2772 still. And the reason for that is we really want to force the issues out. You notice with things like multi-homing, you've seen a full gambit of proposals from just do CIDR like we do today, or all the way to rewrite TCP so you can have multiple source addresses, to, hey, why don't you make the protocol, split the protocol in half and do variable length addressing. And so you see a lot of different solutions. And so Sprint's goal from its beginning was to sort of highlight these things in an operational network where we actually show that, oh, there's a problem here. So we don't hack around the problems. We actually want to highlight the problems so it drives standards work. We use 6-bone space for all customer numbering, and that's because it is tunneled. And when we move to a native infrastructure, we'll start using non-6-bone space, or if 6-bone takes the space back, which they're allegedly doing. And again, we assume that real IPv6 numbering schemes will evolve with the protocol and with all the standards work that's going on. So we don't want to get ourselves into a situation that we can't back out of. And that's really an underlying theme with all of our deployments. So why is it tunneled? Can we afford the capsulation? So on the top, you actually have a router interface with, I'm not sure if it's the peak for the day, but I took a snapshot at the same time and the timestamps below, where you have the input and output of our busiest IPv6 router. And then below that, I took one of our circuits from across the Atlantic. And as you can see, the packets per second, there's not a whole lot there. So while we see a lot of people need IPv6, and they say we want it, from an actual throughput standpoint and the applications that are going on, you know, that's 64 packets per second, you know, 55 of them are ICMP. So
54.
So really, until there's we're doing what the customers ask. So until there's really demand to deploy IPv6 natively and get rid of that encapsulation, we're happy to do it this way because we can afford the encaps, right? There's not a lot of overhead associated with this. So next steps for Sprint, we're writing the transition plan to native based on the standards that are around today, and that's mostly done. One of the parts of that transition plan that's actually a showstopper from a commercial standpoint is when you think about deploying capital and that costs, you can real easily define how much capital you need to invest to put routers out that support IPv6, and we understand what the hardware requirements are. But things like your back office systems, those get into numbers that can get theoretically much larger than your actual capital deployment. So we're building the transition plan, but one of the reasons we're not actually actively transitioning is we only want to do the IT development once. And so if addressing fundamentally changes, which you hear tremors in the IETF about that being a possibility, we don't want to have to rewrite that stuff because it's very costly to develop IT systems, especially for a phone company. One thing we're looking at is can you give customers that native feel without the native nastiness on your backbone? In a lot of layer 2 encapsulations like PPP and HDLC, there's bits that actually tell you what the protocol inside is. So can you take that and look for IPv6 as the next protocol, and if it says it's IPv6 is coming, can you dynamically tunnel that somewhere else? So that'll give you the ability from a downstream, an ISP, the ability to connect to us, use our IPv6 service, not have to configure a GRE tunnel, but we can still actually ship them to a place that's optimized to do IPv6 until dual stack is realistic. So why don't we lead the charge to migrate? I've gone through this a lot. That profit thing keeps coming up. We do what makes money. And IPv6 today is a checkbox on RFPs, but we're not seeing a lot of real commercial business being driven behind it. And some people will say this is US-centric, a US-centric view, but we're seeing the same thing in Asia as well as in Europe. There's obviously a lot more, I think there's a lot more traffic outside the US than there is inside the US, but in terms of people paying customers, especially on the enterprise level, because let's be frank, those are the profitable ones these days. You don't see a lot of real business critical applications on IPv6 yet, but I think it's coming. The router vendors don't compel us to do so. I don't want to blame any vendors, but no matter what vendors you talk to, which routers you have in your network, there's some software and hardware that's not done yet. We don't know how deep the try has to go in terms of doing forwarding. So how can you build the ASICs if you don't know you have to make it 64-bit steep or 80-bit steep or 128-bit steep? You never know what's going to happen. And again, multi-homing, my soapbox about multi-homing. Today you see a lot of solutions, but most of them have, at scale, some pretty dire ramifications. So until we get comfortable with actual scalability of multi-homing, we're going to start to take a conservative stance. And again, I don't mean to beat up on the vendors, but this is another thing that you see in the market is you see the vicious circle where enterprises aren't deploying IPv6 for real, they're playing with it. So as a result, the carriers don't deploy it for real. This is sort of what I've done. And so the hardware vendors aren't driven to do it, which just exacerbates the problem. So I think until you have things like all the next header stuff is there and all the micromobility stuff is there and it's all working in hardware, there's really not a lot of onus. Something's got to give. Either the customers will drive it or carrier hardware, and there will be a business case for carriers to do it and force customers to transition.
That's it?
That's it.
Thank you. So I'd like to thank my panel of people and excuse everyone except for Kathy. No. We have time for a couple of questions? We got 15 minutes for questions. The microphones are there. Kathy. We won't turn them on, though.
Somebody needs it. It's Kathy Whitbroad. I have a comment and a question for Brent. The comment is, I went to one of those IPv6 build a network with the people in the room across from you things, and they're really cool. Like if you're, I learned a lot. I learned that maybe subnetting v6 addresses isn't for me. And, and I learned that even though I didn't believe it at first, that my Macintosh actually began to do v6 all by itself, and that I didn't need to figure out a way to turn it on. So I recommend it. The question I had for Brent was, do you know what percentage of your traffic is v6?
No.
Okay, so there are no problems, but it could be because no one's using it? Which is what we gleaned from the Sprint talk, and bless you, because those are the things that needed to be said.
Yeah, I agree with all the things that were said. I think that people are starting to use it. And I won't say there weren't any problems, but there were very few problems. I mean, basically what we're finding out is that it does seem to exist pretty well in parallel with v4, natively on another router, and that as people turn it on, most of the time it works. Now, for some people, to say most of the time isn't going to be good enough, but I think, as you saw in the workshop, it's pretty easy. You can turn it on. You can do most of the things you want to do with it. There's still a few things you can't do, and there's some architectural problems still. I don't know if that answers your question.
Yeah, that's fine. Thanks.
Thank you.
Just, I guess, two questions really, I guess, aimed at the panel. The first is, I was wondering if you could say a word or two about IPv6 peering. The second question has to do, actually, with what Rob said initially, 7 years working on IPv6. I'm wondering if you've identified either a killer application or a killer challenge that really IPv6 might be well suited for, either now or maybe 2 years down the road that you see. Those two questions.
What was the first one again? Peering. Okay, so IPv6 peering from a commercial standpoint. Here's where big evil Sprint gets soft a little bit. Like I said in the thing, from a peering standpoint, we're willing to talk IPv6 with anybody. Because the whole goal of the project we did to deploy IPv6 is to gain experience, and for the industry to gain experience and highlight some of the issues surrounding IPv6 and force standards bodies to fix them. So from that standpoint, peering is very open. In terms of killer applications in IPv6, my largest beef is still multi-homing, I think, from my standpoint. It's really a matter of if you're going to put IPv6 addresses on your refrigerator and on every soldier's machine gun, you need to have a way to scale the routing system. You know, memory is cheap, but the building ASICs to be able to actually forward at line rate is not, and the technology is not there yet. So there has to be something to scale the size of the routing table. And what you find is deploying things like CIDR in IPv6, you know, fundamentally goes against sort of the goals of the fathers of IPv6.
I disagree about forwarding at line rate. I think v6 will forward at line rate.
Depends on your line.
From the customer perspective.
Depends on your line rate. I mean, my line rate at 1200 baud, I suspect it'll forward at v4 and v6 just fine at 1200 baud. At OC 760, what was it? What was the end? That HFR thing, 768?
768, that's right.
Yeah, I don't think you can do v4 at 768, but that would be me.
But I can do it. But I can do it at you know, at approaching 10 gig as well as I can before.
That's good. Ed. Someone said table size, and their tables are round, but
Tony will tell us.
Hi, Tony.
Hi, Tony Lee, formerly a vendor. I'll point out that former vendor does have v6 forwarding at 40 gigabits per second, no problems. And as far as table size, it's how much do you want to waste? I agree completely that we have to fix the multi-homing problem, but when we tried to fix the multi-homing problem, we were told that we were not allowed to fix it because that would involve changing the way IPv6 worked, and v6 was already deployed, and therefore we weren't allowed to change it and fix it, and therefore we can't deploy v6.
Ed, you had...
we obviously don't peer, not being a transit, but it would be... one thing I do find is that every once in a while I try to find out whether I can reach the other name servers that I involve with, either these zones or these servers I exchange zones with, or the root servers that are on v6. And I do see that connection getting better over time. We have to, every time we find something, trace route and make sure our provider knows that we can't get here. We do see things getting improved. As far as the multi-homing, I think, is important to us too, because that for me is redundancy. I'd like to be able to have more than one provider come into a spot and have my services available no matter what happens to either line. I think that's an important part too.
Yeah, and one of the things that we're seeing in the universities is that people are starting to break the multi-homing problem by doing exactly what we didn't want them to do, and that's going out and getting provider-independent addresses from ARIN, because they can.
That's a good thing.
So, question to the Sprint side.
For the folks that are not here.
Sorry, this is Matt Petak from Yahoo. Not that that's related here, but the question is, you're giving out 6 bone addresses right now to people that you're providing addresses to. I know the multi-homing problem here is something that we're all kind of dancing around and not answering, but are you potentially complicating things further by giving out 6 bone addresses to people who may want to multi-home in the future, who are not going to necessarily be allowed to pass those addresses off to the other people they want to peer with? In fact, kind of an answer to Bill's question, is that not sort of providing an impediment towards the notion of IPv6 peering by having incompatible address spaces being given out by different people?
I think one could view it as an impediment. My problem is, just to be frank, the reason we use 6-bone space is that if things change and we deploy an addressing delegation architecture that is suboptimal, and I give you real, for quotes, IPv6 space, I can't get it back. Whereas 6-bone space, I have the freedom. Everything we offer is built around the fact that it can go away overnight, right? And that's because we need to experiment with it, so we can reboot routers when we want to, and we can change our downstream customers, and all the SLAs are built around the fact that, hey, this is an experimental thing. So yeah, I can see it being viewed as an impediment, but our biggest problem is we don't want to make a mistake with deploying the operational stuff that you need to do it for real, and then not be able to, we don't have the flexibility to change that later if we need to. So that's really our motivation.
I've actually seen, and for the places that I do stuff where I'm running native, I will use RIR assigned space, and the tunnels all have the 3FFE 6-bone space with the expectation that the tunnels will eventually move to native, and then I can move them over to RIR space. That's me as an enterprise. So a couple of people that are enterprises, I also run name servers, and it's nice to see that there's better connectivity and more robust connectivity. What will be scary if there are enough customers that adopt and ask their ISPs for service, and the ISPs don't have the kit to deploy. That will be scary, because I don't want my ISPs put in a situation where they can't monitor and measure, unless, of course, I'm an academic, in which case I don't want them to bill me, right? Kathy.
I just have a question. I don't know your name from Sprint, but
Rob.
Are you saying what you said because you view the ARIN space as space that isn't leased to your customers but given to them for all time? Because, or are you going to treat it like v4 space where it's actually a lease and you could get it back? Because that troubles me.
Sure. Whether it's leased or given for all time, I don't think anyone gives IP space for all time, but it's...
Well, the internet did.
If you introduce expectations that things are running in a certain way, like this is for real, this is operational, it's SLA supported, then that's going to induce behavior for the people that are connected to that network. Everything we did was built on putting forth the perception that this was experimental.
But couldn't you put that perception forth with the other address space? I mean, I'm trying to understand why it's somehow attached to the address space.
Well, I mean, look at all the folks that still have /8s out there, right? I mean, there's in IPv4. I think reality is it's very hard to recover IPv4 address space from your customers. You can null route it, right? But it's still, politically, it's sticky. So using 6-bone space was, the intention was this gives me a little more flexibility in the expectation that I can yank it back at any time. Whereas
there's an RFC that says that 3FFE is going to die.
Right, but I guess in an effort to make new mistakes, we should try to treat V6 space somewhat differently and perhaps come up with mechanisms to get it back.
Oh, absolutely. But that's a different forum.
Hi, Tom Pusateri, Juniper. Yeah, RFC 3701 is the one that says the 6-bone should be phased out, and that the address space won't be routable after June 6th of 2006, I think is what it says.
Well, yeah, that's a piece of paper that you can beat some customers over the head with. Right. Some customers, myself, laugh at you as an ISP and says, you're not going to do what? I'll take my routing somewhere else. And somebody will route my 3FFE space for me. Right? So the IETF telling me what I can and can't route is kind of, the hackles go up.
Right.
Yeah, we're delegating 3FFE space too, but we're slowly starting to pull it out. We're doing 2001 space instead.
I just think the intention is that operators should be prepared to be using normal address space by that.
Oh, yeah, absolutely. Right. But I think that the expectation is if you have 3FFE space and you are an ISP, you can take that document and you can say, look, this is coming back, where there is no equivalent document from either the RIRs or the IETF that says, look, this is coming back for our address space delegated from an RIR. It's slightly different, but this may not be the venue for that. Anything else? Dave.
I just wanted to make, Dave Meyer, I just wanted to make one brief comment on that. I had this experience in the IETF with documents and things like tunneling and address space, and the first document that was ever written in MBUND was written by Jayhawk. And what it said was no more tunneling, service providers should not tunnel multicast anymore. And that's worked pretty well. Like not at all. So I think what we have to do is we have to get off these kind of weird things like tunneling, and we have to concentrate. I mean, we're going to be tunneling things all over the place forever, and so to make that, an impediment for moving forward, I think might be a mistake.
Yeah. Okay. So now we're moving into whether or not VPNs are a good thing, and should be supported because they're just tunnels on steroids.
You might be.
No more questions for our esteemed V6 early adopters? Are you all now prepared to go off and put V6 into play? Okay, we got, I want to wave, okay, start on that side. All right. In that case, thank you very much for your kind attention. Susan?
Thank you, Bob.